Hi folks. In this video we're taking a look at tangent lines and normals. So we've talked a lot about the slope of the tangent, but we actually haven't talked a lot about finding the equation of a tangent. So here it says sketch f of x equals x squared, which is our favorite nonlinear. And we're going to draw the tangent where x equals 3. So let's say this is 3 here. And we can draw this tangent in. I'm just sort of eyeballing it. But there's a point there of 3, 9 where it touches. Okay? And there's some slope. And we can find the slope through differentiation. It's easier now that we have our simple rules for differentiation. But we can also find the equation of that line. And to find the equation of any line, we use the point slope formula, which is y minus y1 equals mx minus x1. It's kind of a rearrangement of the slope formula itself. Or if you like, you can write it in y equals form to start with, like this. I kind of like it the first way, though. Okay, to use the point slope formula, you need to know two things. Can you guess? Can you guess? That's right, we need to know a point, and we need to know the slope. So to find the point, we're going to use f of x to figure out the y value. To find the slope, we're going to use f prime of x, because that gives you slope. So on this curve that we've got right here, I already know that it has the point 39 that I'm interested in. What I also need to figure out is what is the slope at x equals 3. So to do that, I'll think about f of x, which is x squared, and its derivative, which is 2x to the 1, or just 2x. That's its slope anywhere. At 3, well, its slope would be 2 times 3, or 6. So now I know that the slope, which is m, is 6. That's great. Now I can find the equation of that line. So I'll have y minus y1 equals m x minus x1. If I sub in, I'll just head over here. Y minus y1, so the y value is 9. M is 6. And x minus x1, that x value is 3. So we get y minus 9 equals 6x minus 18. Or, moving things over, 6x minus 9. So allegedly that's the equation of this line. But seeing is believing, so let's head to Desmos. There's our parabola, y equals x squared. If I graph 6x minus 9, look, it just touches at x equals 3 right here. And it really does look tangential to the curve, so we have found the equation of that tangent. If we think about where this word tangent comes from, sometimes we'll think of it from a circle, and it's a point that just touches on the circle. There's the tangent. A good example is like the hammer throw as a sport. So you're turning it round and round, and the instant you let go, it's going to go off in the direction of its tangent. There's also a line that's perpendicular to the tangent, though, and that's actually going to be the radius in a circle. Generally, we call that line that's perpendicular to the tangent a normal. So there's another line called the normal, which also meets f of x at x equals 3. It's perpendicular to the tangent. So let's draw this situation again. We've got f of x equals x squared. We've got right over here at 3, 9. We've got our tangent. I'll do the tangent in green. Okay. There's the tangent at x equals 3. And here's what the normal looks like. It looks perpendicular to that tangent. And it's generally somewhat less useful. And this is the normal. Now, it's just a line, so we still need to know, just two basic things, the point and the slope. The thing to remember is that perpendicular lines have slopes that are negative reciprocals of each other. So in this case, if we wanted to do the normal, our point would be 3 for x, 9 for y. Okay, that 9 just came from subbing in 3 here. So f at 3 is 3 squared, or 9. That's how we get this x value and y value. The x value is given. The slope, well, we already did all this stuff. We said f prime is 2x, f prime at 3 gave us 6. That's the slope of the tangent. The slope of the normal would be the negative reciprocal. So we'd flip it upside down, and we'd make it negative. To find the equation of the normal, we still go to point slope formula. You might hear the snow plows in the background there, because I'm doing this right after a snowstorm. Y minus 9, negative 1/6, x minus 3. Now, if the IB only asks you for the equation, you can actually leave it in that form. You can leave it in any form. If you need to put it in your GDC, though, you'll probably need to put it in y equals form. So let's just distribute. That's negative 1/6x, positive 1/2. And so if we add 9 to both sides, that'll be negative 1/6x plus 9.5, or 19/2. You could also have called it negative 1/6x plus 9.5. Okay. Or even, if you wanted to, negative 1/6x plus 9.5, though we don't tend to use mixed numbers very much in higher mathematics. And that's the technique for finding the equation of a normal. You find the slope of the tangent, and you just take its negative flip. So let's do that for one more function. We've got the function 1 over x, which we've actually seen before, so I might as well draw it. It looks like this. Okay, and we want the slope of the tangent at x equals 2. So here's, say this is 2 over here. It's going to have a slope like this. It looks like it's going to be not very steep and negative. So you might notice that this function itself is not in a great form to play with. We can't just use our differentiation rules on the bottom of a fraction. We have to rewrite this as x to the minus 1. And now we can use that power rule, which tells us that the derivative is going to be negative 1 x to the minus 2. And you might want to write that as a fraction after the fact, negative 1 over x squared. And we care about what's going on at x equals 2. So this is the slope anywhere. Slope anywhere. The slope at 2 is going to be negative 1 over 2 squared, or negative 1/4. That makes sense. We said it was going to be negative and not very steep. Now, for part B, we need to find the equation of the tangent. So that's this green thing here. So maybe I'll switch to green. We need to know the point and the slope. Well, we found the slope already. At that particular instant, at x equals 2, the slope is negative 1 over 4. The point has an x-coordinate of 2, and if we want its y-coordinate, we need to sub in to the original. So f at 2 would give us 1 over 2. So there's our point. Okay. The slope, on the other hand, of the tangent came from f prime at 2. We've got a point, we've got a slope. We are primed to use the point-slope formula. So let's sub in y minus 1/2 equals negative 1/4 x minus 2. And we'll just follow it through. Y minus 1/2 equals negative 1/4 x plus 1/2. And if you move that half over, if you add half to both sides, it'll be negative 1/4 x plus 1, which kind of looks like what's happening on our drawing up here. It's got a positive y-intercept. The other thing that we'll look for is the equation of the normal. Okay, so I'll try and make that look perpendicular. Assume that's a right angle. It's probably going to have a negative y-intercept. It's going to have a bigger positive slope. And we can just work this through. The point is no different. Okay, the point of connection with the graph is still this point right here of 2, 1/2. We know that, so there's our point. We know that the slope of the tangent is negative 1/4. So the slope of the normal, which is perpendicular, will be flip it over and change its sign. So the negative flip of negative a quarter would be 4. And now we go ahead and we use our point slope formula again. So y minus a half. And I couldn't guarantee that the point slope formula is in the formula booklet. You might want to take a look. But it's one that we use so often that hopefully it will get memorized. If I add a half to each side, I'll get, I could say minus 7.5, or 4x minus 15 over 2, or, reluctantly, minus 7.5. Any of those are fine. Probably the first two are ideal. Maybe the middle one is really the one that you want. So there's a tangent and normal worksheet in the video description below. And you can pick away at some questions there. Try and do at least a half dozen of them. I hope this has been helpful, folks. Good luck with the material, and take care.